Maybe the most diffuse and old one is the pumped hydroelectric storage. In this case, we transform electrical energy into gravimetric energy because we move water from a low level to a high one. So what we need usually are two basins that needs to be at different level, or more or less at least 100 meters of difference between the two basins. And we use electrical energy to pump up water to the high basins, and when we need electricity, we use the gravimetric power to into a turbine that is connected to the grid. Usually we have big plants, so we have large scale with also high efficiency and long storage periods, but maybe the drawbacks is big plants that usually have high total cost, and due to the characteristic of the technology, we need a sort of available site when we have mountains maybe, or higher and lower basins available. Otherwise, the environmental issues are very big because we need to make a lot of civil activities and civil works for this kind of system. Somehow similar, so in several aspects, is the compressed air energy storage. In this case, the idea is to use electricity to feed a compressor that will increase the pressure of air that needs to be stored in an available volume, maybe a mine or underground caves. And then the high pressure air is released and to a burner where we mix, for example, natural gas. So we have hot gases that can feed the turbines to produce electricity back to the grid. Also in this case, we have commercial available technology with large scale and pretty good efficiency and long storage period as far as we can keep air into these volumes. Drawback is again that we have big plant usually, so high total cost, we need availability of site, and of course some environmental use issues related to all the big dimensions that usually impact what is the environment around. Another very diffuse technology and very old technology is Flywheel. In this case, electrical energy stored in kinetic energy. There is a volume, a cylinder that is rotating, and we can accelerate or decelerate this volume, taking advantage of the kinetic energy that we can store into increasing the velocity of the rotation or reduce it. This becomes a way to store energy. For sure, it's a very old and well-known technology that does not degrade as technology over time, and with very good efficiency, above 90%, and very fast response to grid requirements. On the other hand, the energy can be stored for a short period because we have friction. We may have, now it's improving, more or less friction, but of course this storage doesn't last for a long time and has also low power density. What is the most diffuse, the most interesting, and somehow under investigation technology are batteries. Also, this is a very old and well-known technology, and it's very difficult to reduce batteries in only one big group, as we try to do here. We have at least to define 4 different kinds of batteries with very different aspects between each others. We have the well-known and used lead-acid batteries. And also nickel-based batteries that are being used since now, and in a more mature and well-known development. Pretty also well-developed nowadays are the lithium ones that were diffused for a portable application, as we well know for any our mobile phones. And what is recently also becoming more and more interesting in literature are the sodium sulfur-based batteries. If we want to give a general definition, we can define the mature technology. As I told you, not all the technologies are mature, but like lead acid are well known for sure, and high efficiency, fast response time, and low cost. These are technologies that are mainly based in electrochemical solutions. So we have an anode and a cathode where we can store electrical energy, and thanks to the solution that are the one rechargeable batteries, we can change the chemical state of chemicals inside the batteries to get back direct current from the batteries. Going to the drawbacks, of course, we may have short duration. That this depends on which kind of technology, and we have scale-up issues that usually are related to a technology that starts from small and portable devices. And we have also an issue mainly for some technology like the lithium-based one, that critical raw materials are not abundant in the earth, and so they may have as technology a high environmental impact. Continuing in the kind of electrochemical device, what is also pretty interesting are the flow batteries. In this case, it's again electric storage into chemicals, but we have a flow that separate liquid flow that gets inside the batteries and allows us to separate what is the energy from the power. That's a pretty important one compared to batteries. And this technology usually have high efficiency, long storage period, exactly because we keep the with the chemicals separate in a separate storage, and it's easy to scale up. Drawback, of course, is that it's a low energy density. This is related to the chemicals that are now being developed for this kind of technology, and of course it's a new one, so we have a low level of development. Another interesting technology and well known are capacitors. They come from the electronic technologies. We have two surfaces that are divided by a dielectric, and we can charge one of these two surface with a positive charge and the other one with negative, and then it becomes a storage solution that is related to the sides of the dielectric inside and the side of the surface that we use for the capacitors. Is very fast in reacting to energy that needs to be supplied and recovered by the capacitors, and compared to batteries, has no limit in the amount of cycles, or suffers very low on the degradation due to the amount of cycles of charge and discharge, and pretty good efficiency, around 60-65%. But the drawbacks is low power, especially low energy density. It can be expensive for large scale application, and of course there are no experience for high scales. It's not being developed since now. Finally, what is extremely interesting and will be later on deeply described is the hydrogen-based chemicals. In this case, we can store electrical energy into chemicals, producing by electrolysis hydrogen, and then maybe combining with other chemicals to have a sort of fuel production. And usually the energy density is very high, easy to scale, and with a long storage period, so it's extremely interesting for transport application. On the other side, the round-trip efficiency is still a challenge for this technology, and due maybe to the low level of development that has also forced an effect on the high total cost. Safety also may be an issue for the technology. In general, these are 7 main technology that are nowadays developed, and they have advantages and disadvantages, and it's not easy to compare if we don't have a strategy for the energy store. So what we usually can find is compare with some graph that maybe, for example, compare energy density and power density, or maybe the duration on time. But what is most important thing is that we need to identify which are the main parameters for our application that are mainly related to what is the storage strategy, so what is the requirement of coupling the producing energy producers and the users of energy, and of course what are the opportunities that the site where we can realize the storage technology offers to us. Thank you.